We have a packed show for you this week. To start off, we talk about Volkswagen connecting with EnerKite, and Rosemary has done a bunch of research on these kite projects that generate power and what it means and is it a good idea. And then we look into small wind power with Ryse Energy, which has been supported by RWE.
We're going to talk about our friends in PES Wind Magazine this month, or this quarter, I should say, over from North Dakota, Thread, and what their software solution and drone enterprise looks like.
And then we're going to head offshore. Scotland is installing the world's deepest fixed bottom offshore wind turbine at, I think it was 68 meters. And there's also a 100-meter monopile from Entrion that they're proposing. And we delve into a little bit about floating offshore as well, and about how that's going to compete with fixed bottom in the long term.
And then our wind farm of the week is Western Spirit Wind in New Mexico, so stay tuned for it. I'm Alan Hall, president of WeatherGuard Lightning Tech, and I'm here with my good friend from Wind Power Lab, Joel Saxum, and Australian renewables guru, Rosemary Barnes, and this is the Uptime Wind Energy Podcast. Rosemary, I know you have talked about the flying kite power generation systems, and Volkswagen must have seen your videos. So Volkswagen Group Charging and EnerKite have submitted a proposal to the federally funded TechnoHive project, which involves using airborne wind turbines to generate electricity for mobile charging points. And EnerKite will provide flying wind turbines, which the company claims could yield twice the annual energy compared to ground lodge turbines. The system uses wind-catching kites to pull a rope, producing large forces that are converted into electricity. And the project is called Autarkic Mobile Charging Infrastructure, and it will run through the end of 2024. EnerKite is led by former world champion in speed kiting, Christian Gebhard, and they're working on the first product stage for the EK200, which is the model of this kite. And Rosemary, you had done a bunch of research on this on your site. Does this make sense to use kite to power up mobile car charge ports?
Maybe it does. I was interested to see EnerKite with this agreement, because then they're not the front runners. I mean, they're one of the front runners, I guess, but I hadn't seen any commercial sales from anybody other than Sky Sales and airborne wind yet. So it's good to see that diversifying a bit, but it's not EnerKite, as far as I know, and according to their website, they don't have a product ready to go off the shelf yet. They're still testing prototypes and stuff. So I guess that's why it's a research project with Volkswagen. So in the long term, I think it may make sense, but there are a few issues that need to be taken care of first that I find it hard to believe that they're going to be ready by the end of 2024, ready to actually start rolling these out. The biggest one is just regulatory. At the moment, all of the flight of these systems, at least in Europe, all the test flights are in special test areas. They haven't yet figured out how it's going to work when they're flying above, roads or, anywhere near where people might go, which presumably they would have to if they're going to be powering, charge points, unless you want to also build really lengthy transmission lines to get the power there, then you're going to be putting them in built up areas, and you're going to be worried about what happens if there's a crash and a kite falls down onto the road or something like that. So I would say regulation is going to be the biggest and longest hurdle, because it's not just that EnerKite has to demonstrate that their system is safe. There needs to be a whole regulatory system developed that they can fit into, because obviously the EU doesn't just allow anybody to, fly whatever they want, wherever they want, right? I mean, you'd know about that. And then there's a few technical problems like that no one has solved yet, including EnerKite, which is autonomous launch and landing, and also, how it goes in difficult weather conditions. So, like I said, SkySails is the furthest advanced in this technology, and they have their autonomous launch and landing roughly ready, or it's ready under good conditions, but they still have, I think, 2.5 operators on hand at all times. So it's like two people and an assistant, or maybe it's 1.5. I can't remember. Anyway, more than one person that needs to be there to actually fly this stuff. They've got a pilot and a co-pilot kind of, and obviously that massively affects the commercial viability of it, but it's a temporary thing while they iron out the kinks. But I think with SkySails it's a bit of a different commercial strategy, because their initial sales are mostly like islands, they're actual islands, so they're island grids and also physical islands. So they're replacing diesel generators, and diesel in remote locations is so expensive, and so they have like a really strong incentive to try something else that works. And with a airborne wind energy system, you can install it much quicker than you can a fixed wind turbine, and it's a lot less permanent. So if you're putting it in a sensitive environmental area, then you don't need to dig and build a foundation. It just all comes in a shipping container, and you just unpack it from there in a day or two. So to me, the island application makes much more sense for that early adopters kind of part of their growth plan, because there's a lot of good reasons why these applications can't just use regular wind energy. So it doesn't really matter that it's more expensive and more of a pain for now. So they'll be able to work out those issues on those customers. Whereas for car charging, I mean, obviously this is going to be in areas where there's a lot of people and there's going to be an electricity grid nearby. There's plenty of regular wind farms that are connected to the grid. So, I guess that it would make sense if they couldn't install a regular wind turbine for some reason. But if they could, then that would for sure be the cheapest option now. But I do agree that there's at least a possibility of this ending up the cheaper option in 15-ish years maybe. So if they're thinking long term, then it's good to have a bet on a bet each way. So a bet on this side makes sense to me.
Joel, have you ever been to Burning Man?
Should I answer this question?
Well, it may incriminate you.
All right, I've been to the Burning Man grounds. I've never been to actual Burning Man festival.
All right, so that it used to be it was just you take a tent, you stay out in the desert and have a quote unquote fun weekend. And it's gotten a lot more upscale recently, where they have sort of air conditioned tents and all this and catering and all this stuff. The problem is there's no power out there, right? So isn't this EnerKite solution a perfect situation where you're out in the desert for a week and you put a bunch of these kites to power your Tesla and your tent and your catering service?
I think so. So I see it in a couple of different realms as well. So I think emergency and disaster response. So in the US, thinking FEMA, Red Cross, if you can roll in with a semi, you might not even have to take the shipping container off of a semi-trailer, pull in with the semi-trailer, launch, and now you've got kilowatts of power for everybody around, and you're not running diesel fuel, you're not creating all those fumes, those things. If you've ever been to Burning Man, the same thing, they had these issues at the festival a long time ago. Not a long time ago. They have it ongoing. But they first brought it up a long time ago was there's so many nasty fumes in that area of it's just generators running all day long, every day, right? So you're smelling that, you're like, oh, we're going to go out to the desert and be one. And then it's just diesel fumes and gas fumes all the time. So you have that issue. So the same thing, like if you're, and I know this is a stretch, right? But like I'm thinking tailgating, RVing, all these different kind of things, camping, that off-grid type stuff. Been looking at some campers lately, my better half and I have, and it's amazing to see how many of them don't have an option for any kind of solar panels or anything of this sort. It's all aftermarket stuff. I would think that almost every manufacturer, I mean, you've got some of these, we're looking at trailers to pull behind the truck, right? So some of these are 20, 30, 40 feet long, all this roof space, no solar panel. Like that should be one big solar array up there in my mind. And with a battery bank.
That's bizarre. Is there some sort of like ideological opposition between RVers and solar panels? Because definitely those types of vehicles in Australia are covered in solar panels because that's by far the easiest way to get electricity, and it's quiet and you don't have to refuel it and it doesn't smell.
Yeah, in the US, when you walk into the RV dealership, the first you run into banks of generators before you run into a little thing of solar panels. And the solar panels a lot of times are like the size of a notebook, and it's like, this is a battery tender to keep your one battery for raising your platforms up and down. It's like, why aren't we running the whole camper that way? Yeah.
That's insane to me. It must be like willful. It must be on purpose, because even, you know, like actual just car campers where you get a literal tent out of your backyard, out of your car, and you camp in that. Plenty of people like that will then, you know, unroll a bunch of solar panels and use that to, you know, power a little cooler or, recharge their phone, something like that. It's just, it's very convenient and cheap. And
do you guys have Goal Zero?
I don't know.
So Goal Zero is off-grid living, basically. It's solar panels, and they have battery banks and chargers and all this kind of stuff. And that, like, every once in a while, you'll see some of those things for sale at one of these RV dealerships. But in my mind, I would think, why not have a pop-up mini wind turbine and have but it's only specialty brands. And I think it's just a cultural thing. A lot of the people buying RVs of that sort in the US are the older generation that's now retired and they're going to go travel around. And that's not really what they're looking for. But you'd think it would be a perfect convenience. Like, oh, hey, by the way, now if it's bright out, you don't have to charge your batteries by running a generator. But it's odd. I agree. But those are the things I'm thinking of. A miniature version of like this EnerKite thing. If you're anywhere where there's any wind and you had this in a box on the top of your camper, up you go, and now you've got power.
There is one available. I'm just Googling it now so I can remember the name and check if it's actually available for order. And I would love to get my hands on one of these and test it out for the channel. But it's by Kite X, and it's called the Wind Catcher. And it's the website's being slow to load, but it's a small portable system. You unfold a campsite, and I'm going to assume that it's not autonomous, but it's. There is a portable one.
But if you had, I envision a camper that has an app. Everything has an app, right? You should be able to pull your phone up and be like, just like the Tesla has, and be like, oh, hey, your batteries are at 40%. Oh man, we should launch the wind turbine to charge them up. Up, charge them, down it goes. Now the kids can watch Netflix in peace.
Rosemary, since you went to UC Davis, did you go to Burning Man? That's pretty close.
No, I didn't, but I would love to. And I think Joel's definitely, or both of you are right, that this would be a great addition to solar panels is the obvious thing. If it's in the desert, then, you know, you're going to have clear skies during the day, most likely. So some solar panels and batteries would be your first step, but that would be a great place to add in these airborne wind energy once they have ironed out the kinks and got the regulation sorted. Definitely.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
RWE has been busy again. In a $15 million funding round, RWE Energy Transition Investments has led the growth funding round of Ryse Energy, a UK and Spanish manufacturer of small wind turbines. Ryse Energy, which has already installed more than 4,000 small wind turbines, plans to expand its energy as a service model, enter new markets, and expand its technology offerings with those funds. The new markets Ryse Energy is targeting include the USA, UAE, and possibly India. Makes a lot of sense. The company plans to invest in its new technologies, become certified for a number of markets, and expand its manufacturing capability. And RWE thinks that Ryse Energy has the potential to be a major force for good in reducing greenhouse gas emissions and providing some reliable and sustainable energy access. RWE, again, it seems like week after week, RWE is doing something interesting in the renewable energy space and investing in small wind. I think this makes a lot of sense because there are, like we just talked about, there are a number of potential uses for it that it hasn't grown to the place where it probably should be in America right now. Joel, do you think? It seems like there's not a lot of small wind here right now.
No, absolutely not. And I think Rosemary has done a couple of videos on small wind turbines as well, and where they're good and where they're not. Of course, talking about ranch lands, farmlands versus inner cities, and those kind of things, and where it actually fits. But again, the U.S. The general population, depending on where you are in the country, has not taken a hold of this distributed grid, small, make your own power type stuff. We drove into this, we're in Houston now, we're in the suburbs here, and driving into this new subdivision where my better half and I are staying here for the next few months, we saw solar panels on the roofs, and I was like, oh man, this is awesome. Finally, someone diving into solar panels on roofs, because in Texas, in the suburbs, you just don't see that because they don't look that good on the roof or whatever, but you might have, 300 homes in a square mile and not a solar panel on them. And you're thinking, and it's Houston. They should be on all these houses. So I was happy to see them here. The same thing. I, to be honest with you, I've traveled all over this country from left to right, and I can count in one hand the amount of small wind turbines I've seen. And all of them have been on ranches, and most of them have been in Wyoming, to be honest with you.
So that's interesting. That's kind of similar to Australia for wind, but for solar, I mean, everyone's got it regardless of your, how much you care about the environment or what your political leanings are. It's just, it just makes so much sense. And it's very easy and cheap in Australia compared to the US. So it makes more sense here than it does even in Texas, where you've got lots of sun. But I also keep an eye out for small wind when I'm traveling around, and I do see it every now and then. But what I'm looking for is that turbine turning. And I don't know, I haven't been keeping statistics, but definitely less than half the time they're turning, and sometimes they're spinning so fast I'm pretty sure that it's not connected to anything. It's just, it's a pinwheel, decorative, which is fine, especially vertical axis wind turbines do just look super cool as a garden ornament. So, it's expensive if you buy a turbine and just use it for a garden ornament, but that's up to the owner, I guess. But I think this plan by RWE and with Ryse, it's a little bit different to that, though. I don't think that what they're expecting is that people are going to be buying these units and sticking them on a house in the suburbs. Like you said, I've done some videos on that, and I mean the wind resource is just not right to do it in an urban area. Wind speeds are too low because there's buildings and trees and everything blocking the wind. It's very turbulent, so that makes it hard on the wind turbines. Plus, they do make some noise and some vibrations, so you're going to struggle there. If you want to get a decent amount of wind, you really want to put it at least 10 meters up on a tower, and, like local planning doesn't necessarily allow you to have a 10-meter tower in your backyard. I wouldn't be that thrilled if my next door neighbor put a 10-meter high small wind turbine. But the kinds of markets that they're talking about, it's similar to what I was saying Sky Sales are doing, trying to displace diesel generators, because it's just so expensive to run a diesel generator. So you have, it's an easier entry for any kind of startup wind energy. If you can displace diesel, then people have a lot of money that they're willing to spend on that. So it's distributed sort of in the sense that it's going into rural communities and probably places that either are not connected to the main grid, or they're not well connected, or in the case of Australia, there's a lot of talk about resilience because bushfires come through and sometimes cut places off for weeks or months. You might be cut off from the main electricity grid. So there's a lot of work in place to try and get more resilience at the end of the transmission line. So those are the kinds of places where this would make sense. And I am really pleased to see more emphasis on small wind, and especially on certification of it, because it's really lacking that there's certification of these kinds of systems. And so even when you get people that have a good location for a small wind turbine, and I think that this project that's talking about, I think it said like 3 to 60 kilowatts. So it is a home or a small farm sized amount of power, or a small community, I guess, at 60 kilowatts. You've had a few of those, and that's can do quite a few homes. So even where people, might live on a ranch that is expensive to, connect all the way to the grid, they're buying the small wind turbines that are available to buy now are mostly not certified, and you just get so many people. Search it online, you'll see so many people that have just bought something that did not do what it said it would. They often break quite quickly, and then like they're rated at some ridiculous wind speed, or the sales information is either incorrect or just so, misleading that people are generally not buying small wind turbines and just being really, really happy with it. So I think that it's definitely needed to get the certification right. There is a small wind certification. There's only like 5 or 10 different turbines on there, but they will test it under, specific conditions, and then they will say, how much, not just its peak power, but how much did it make over, a period of testing hours. So that will be good.
I got a question for you, Alan, and maybe it's because this is a U.S. economics thing. So I'm doing a little armchair thinking while Rosemary is giving us the good technical detail. What if a bank or some other institution, a co-op or something in like Western Kansas or Texas, Oklahoma, came up with a tool that was a capital tool to be able to support more of these being installed? So what I'm thinking is the reason that a lot of these aren't installed, it's a capital expenditure that people just don't have the money for. I don't know exactly what a 50 kilowatt or a 60 kilowatt or 40 whatever costs, but if you had a bank or some kind of financial institution that would come and say, hey guys, we would like to help expand this as an ESG stamp or whatever you want to say, let's install these on homes and we'll share the upside with you. So if you're getting paid back from the grid once you're connected and once you use up all the power you need, and then you get, because that's kind of how the program works in the US at least. If there was a bank that would create a loan program or a function of that sort where they would share in the upside of it, I think you could see some more of these getting installed. Because right now it's one of the barriers to entry is capital, right? It costs money to get these things installed. So maybe if someone stepped up to the plate and said, you know what, we'd like to help with this distributed grid idea. To help the general public, maybe they could build a function within a financial or economic function within a bank or some other financial institution to help out.
Yeah, I think there's some obvious places where that can happen. Texas, Oklahoma, Kansas, Iowa, Nebraska, even up in South Dakota, those things are possible. And because there are a number of community banks in those areas that are really tied to the surrounding area, they know their banker, that plays into helping out the community. And I think you're right. It's a question of, like Rosemary is saying, some of these wind turbines are big enough. They can support 4, 5, 6 homes on them, or one large dairy farm. So you're all the way up in Wisconsin. It may be the same thing. And until there's financing for them, it's really hard for a single homeowner to take the plunge. And Rosemary's also right. In the Midwest, I think a lot of people have tried it and gotten burned over the years. So think back in the 1980s until now. There's been a lot of companies kind of come and go. That certification is really important. If they're going to buy something of that expense, they need to make sure that it works and does what it says it's going to do. Again, the banker makes a big difference there.
In terms of financing, I recommended a book to you last week after the podcast. We were chatting, and I recommend that you read. I can't remember what it's called in Australia. I think it's called The Big Switch. It's by Sol Griffith, who started Electrify America and also Australia. He's big on financing for electrification opportunities for homes, for homeowners. There are a few options in Australia for solar panels, and I don't know if all of the things that he talks about in his book are available yet, but it's talking about things like, if you install a heat pump instead of a gas boiler, in Australia at least, that is that's cheaper than, so you'll save money on your bills. And the same is true for a lot of different electrification things. Same with, electric vehicles, that your running costs are going to be cheaper than if you have a petrol car because of maintenance and fueling costs. So there are banks that will give you a loan based on the idea that you're going to have more disposable income to, the saving that you make is the payment that you make. So that's available for solar panels, at least through, I think it's Macquarie in Australia. And yeah, it's definitely a big opportunity and something that needs to happen to really accelerate electrification, because, over the total lifetime, all of these new electrification technologies save money, but it doesn't help you if your boiler is broken today, and you only have a small amount. You want to spend the least amount of money today to replace it, then you're going to replace it with another gas boiler. But if you could have some finance that covered the gap, and then you repaid it based on your bill savings throughout the life of the product, then that would be a much lower hurdle to overcome. So I think, you've raised a really, really critical point that financing is something that needs to mature for this to, take off rapidly.
Yeah. And as we always say, like the borderline or the stop on financing is insuring, right? So the stamps from whoever's going to certify these things go a long ways to insurers accepting it, because nobody's going to finance unless you can insure it. They're going to have, everybody wants their protection, right? So if we can work towards getting all of these things certified, or not all of them, but the good ones certified, and they have a stamp on them, then they can be insured, then we can finance them, and we can move this thing forward faster.
So the new PES Wind magazine came in the mail. If you haven't gotten your copy, check out peswind.com and you can just download it. And I was thumbing through there. There's a lot of good articles. It comes out quarterly, so when you get it, there's a lot to read. There's good material throughout the whole magazine. There's an article on Thread, and Thread is based in the United States. It's a drone company, but it's got a little bit unique spin. And I'm trying to understand all the things that they do, and I'm really just starting to learn about Thread. Joel, I know you know a lot more than I do on it, but can you explain sort of what the model is for Thread? Because it's a little bit different than other drone companies.
I would dial back one step there, and I don't think I would classify Thread as a drone company. I think I'd classify them as a software company. I'd classify them as a software company, right? Because they're building. While they have created some drone technology to inspect wind turbines, they're also using drones to collect data on utility assets and other things of that sort. But at the basis of it is the software platform for diagnosing what the state is telling you, right? And being able to properly manage it. So one of the things that they're doing in wind, I know, because I've talked with Pete over there and Gray Byers, their chief business officer, a little bit, is they're enabling, and it's really smart, they're enabling the asset owners or ISPs or even OEMs to be able to inspect on their own for wind turbines. So in Wind Power Lab, we're always preaching to some of our clients, like, let's motivate proper inspections. When drone inspections hit the market, autonomous drones specifically hit the market, they started to get so cheap that everybody was just like, boom, 100% of the fleet, let's go do an inspection. And there's a lot of people that still do that today. And you're there, there's nothing wrong with that, but you're catching, possibly propagating issues, and you're getting an update every year on every turbine and this. So those are good things. But I think if you look back now and say, okay, autonomous drone inspections have been around for 5, 6, 7 years. And if you were to look at the inspection results over 5, 6, 7 years, I think in a portfolio, you're going to see a lot of turbines that you may have paid $350, $400, $500 for inspection, and nothing really happened. Nothing changed, right? So one of the things Thread is doing is, while they're enabling the people on the ground to do it. So instead of XYZ Wind calling ABC drone company to come out and do their annual inspection campaign, paying for mobilization, paying for weather downtime, all these different, shutting wind turbines down when they may be in peak wind that day. Like, they may be creating a lot of kilowatt hours and being very profitable, but since the guy is on site and we got to pay for him, we got to shut these things down and let him inspect. Where if you had a drone on site, some people trained to use it. I mean, it's autonomous technology, so you basically have to have a Part 107 and be able to land the thing if something goes wrong. It doesn't take a whole lot of piloting skills to do that. No offense to anybody flying autonomous drones, but it enables basically the inspection arm of any asset owner, ISP, whatever, to be more efficient and effective, right? So they can be more cost effective. And hey, if there's low wind today or we're not doing anything, let's go up and do some inspections. Or if we had lightning roll through a wind farm yesterday, let's do some inspections. I know we're always saying that in Wind Power Lab, like, you know, regularly inspect. If you had lightning come through, check the turbines or check this side of the wind farm or whatnot, if you know where their lightning strikes were. But if you're waiting a year now to inspect and you know that you don't know if you had lightning damage or not, you might possibly have some large issues looming. And that's when we see a lot of blade failures, right? Because sometimes you have inspections where damage just grows and grows and grows and grows. And if you would have stopped it on day 10 or day 1 or day 2 instead of day 180, you would have saved money in the cost to fix it and or could have saved a catastrophic failure. So that's one of the things I know Thread is doing is enabling the people on the ground to be able to do their own inspections. I think that's smart. And another thing is, you know, they're a big data platform. So they're trying to take in as much data as they can and help people be proactive instead of reactive. Right.
Their data platform is called Unity with 2 I's, but that seems to be a big driver for a lot of owner operators is the data platform. That if that interface is not workable, they just don't like to use it. But I think in Thread's case, they're really working on making that interface helpful to the owner operator, right? Because if they're going to be doing their own inspections, kind of what they're doing, then they need to be able to quickly sort out what's what and focus attention where they need to. And I think that's where Thread is going. It's a unique business approach, right? It sort of takes out the middleman out of the inspection process, and probably needs to, right? There's a lot of wind farms that need that service and still will. But I think some of the wind farms and the operators have moved on, that they figured out how to do that and just need a tool, which is what Thread is providing.
Yeah, they want to make the process more efficient, right? So when you talk about integrations, like if you're an autonomous drone company and that's what you do, you may not have the expertise on staff to have an SAP integration or, you know, have a proper API handles into someone's system. These larger operators, they don't want to have, I know I don't. I hate when I have to log into Netflix and YouTube TV and Hulu and have 3 different logins. I would hate to, you know, be an asset operator or O&M person responsible and have this login for this platform and this login for this platform. And so I know Thread's got some smart software guys. It's a lot of the larger, we'll say like software / data acquisition companies do to be able to integrate into some of these players. So I think that we're starting to see a more advanced version of what was a drone company, right? You have the Zeit View guys that have recently got a bunch of cash and they're evolving. They've got a big back office staff that is software heavy as well, right? They're very smart at what they do. SkySpec's $80 million, right? I know Thread, they came out of North Dakota as a drone company, right? And they got a bunch of non-dilutive funding and now they're growing and growing and growing. So you're starting to see like drone company, inspection company 2.0 pop up as opposed to, hey, we can offer an autonomous drone inspections. That's great. Now everybody can do that. What else do you got?
Rosemary, isn't that the dream though? If you're a blade designer and having to maintain blades, don't you want just to be able to have access to images that are more recent than 6 months ago?
I'm not sure if it's a dream for the manufacturers. It's a nightmare for them because you're going to pick up a lot more stuff. But it's certainly something that, you know, the kind of work that I do with, you know, working with serial defects in wind farms and root cause analysis and stuff. When you're in that phase where you're trying to figure out, you know, how worried do we need to be about this problem? You know, we've got a few failures, usually the first 1 or 2 you found out about accidentally because, you know, you just happened to be doing something else to that blade and noticed something. And then, you know, root cause analysis, the affected population tends to grow and grow and grow for a while. And you never know how quickly something is going to progress. That's one of the problems with composite materials. You can statistically say how fast, the damage is going to be apparent in a population. You can do testing and say, we expect this defect has a fatigue, a blade with this defect has a fatigue lifetime of, 1 year instead of 30 or 2 years instead of 30. But that's statistical. That doesn't tell you any individual blade, and you can never have very much confidence. And the problem is that, once the defect starts, the way that the crack propagates, it's not like it's going to, even if on average it's going to make, 20 millimeters over a year, this crack. It's not happening, 1 millimeter every month. It's like nothing, 10 millimeters, and then nothing, your blade's broken. That's kind of how it works. And so when I'm getting involved in these cases, I'm like, the manufacturer is always like, oh, we're sure that this is not going to happen quickly. It's, it's all fine. We'll continue inspecting the blades once a year. And I'm always wanting more information, and to be a little bit more cautious for the way that they're running the wind farm. And it is going to be so nice when we have more options available to be inspecting much more frequently. And in the case of lightning, as well as what Joel was saying about, catching a damage early before it, breaks, before it's a catastrophe, it's not just about preventing the damage, it's also about assigning blame. So, if you catch a damaged blade the day after a lightning strike, and, you're pretty sure that the lightning strike was within the parameters that it's certified for, then it's quite easy to be like, okay, the lightning system didn't behave as expected. Whereas if it happens a year later, you're not sure what lightning strike did it. And also, a little bit of damage that could have been repaired in, a couple of hours with a couple of rope techs. That's different to then, we just let it run and now the blade's broken. I mean, that's, you're not going to get the manufacturer to pay for that because you couldn't be bothered to inspect it. So I think there's so many benefits to being able to inspect much more frequently. And, I say this nearly every time we talk about easier maintenance, but it's going to be especially critical offshore. We can't keep on doing maintenance and managing defects the same way offshore as we do now onshore. It is not going to work once we have, so many offshore wind farms. So we need solutions like this.
Joel and I were just talking before the podcast about a wind turbine that got damaged by lightning a couple of days ago. And I went back to look at all the lightning strikes that had occurred in that general area. This is sort of the middle of Kansas. Over one evening, there had to be 1,000 lightning strikes.
Or more. It was crazy.
It was insane. Right. And so you just know when those kind of storms pass over your farm, you probably have lightning strike damage, or there's a pretty good chance you've taken a number of lightning strikes. Damage is the question mark. You need to be checking that. When those storms hit, the next day, you better be out there doing some inspections because, like you're right, Rosemary, if you don't catch it at the right time, it could be catastrophic. And sometimes those cracks propagate faster than you think. It's the perfect case for a thread, right? It should be able to go out there the next day, fly the drone, check out your turbines, go, yes, we're good, or no, turbines 2, 8, and 12 need to be shut down until we can get a closer look. We got to call, Wind Power Lab to come in and do an internal inspection. There you go. There's your case, right?
The other thing not to be missed here is that when you go to Blades USA, when you talk to anybody that is in the blade world, they're talking like, man, if we get more data, if we could look at this, we could look at this. This has the capability. These advanced software platforms have the capability and that quick ability to go and inspect and collect this data. Has the ability to give blade engineers and blade O&M specialists, this data to be able to look at. So use case, look at offshore wind, like you were talking, Rosie, and leading edge erosion. If you're looking at leading edge erosion and you look at 1 year, 2 year, and you can see the general propagation of it. Now there's quantitative studies out there to get into forecasting this, but qualitatively you could just look at it and say like, okay, basically this leading edge erosion is advanced to a stage at 2 years where we need to do something about it. And if we do the same thing again, then we're going to be back here again in 2 years spending $1 million with an SOV doing an LEP campaign. So now that we have all this data and we can see how long this is actually going to last, we figured out what our OpEx budget looks like. We need to change something, or we can continue to do the same thing, whatever. But you're getting more data this way to be able to make those decisions properly.
Ping Monitor is a continuous blade monitoring system which allows wind farm operators to stay ahead of maintenance. Wind techs can often hear damaged blades from the ground, but they can't continuously monitor all the turbines. They also can't calculate how bad the damage is or how fast it's propagating based on sound, but Ping can. Ping's acoustic system is being used on over 600 turbines worldwide. It allows operators to discover damage before it gets expensive and prioritize maintenance needs across their fleet, and it pays for itself the first time it identifies serious damage or saves you from doing an unnecessary visual inspection. Stop flying blind out there. Get Ping's ears on your turbines. Learn more at pingmonitor.co.
All right, so there's records being set all the time across the world in offshore wind industry, and Scotland is a place where a lot of those records happen. Well, the Scottish energy company SSE has set a new record by installing the world's deepest offshore wind turbine foundation. The 2,000-ton foundation was installed at a depth of over 58 meters, and as part of a $3 billion Seagreen offshore wind farm, which is being developed in partnership with French oil company Super Major Overall. The wind farm will be fully operational this summer and is capable of powering an equivalent of 1.6 million homes. Holy moly. That's a lot of homes, guys. SSE's Chief Executive Officer, Alistair Phillips Davies, said that the installation marked a significant step towards completing the project and demonstrating how the company is pushing the boundaries of technology to drive change. SSE is planning to invest £12.5 billion by 2026 in various renewable energy projects. Wow. 58 meters is a long way, Joel. That's pretty deep.
58 meters is the depth of the water, right? That's the depth of the water. So think about this now. That 58 meters is the depth of the water. You're going to be at least 10 to 20 meters below the mud line. And then you're going to be another probably, 7 to 12 meters above the water. So you're thinking 60, you're 80 meters high. And I believe this is, if this is a foundation, this isn't a monopile. So this is a jacket. So this thing is huge, like absolutely massive. I think you're setting a football field on end and building it out of steel. And then think about the width of the foundation. Like it's just massive. Like to stand next to something like this it would just blow your mind.
Can I just step in and be a little bit pedantic about this? It's the deepest fixed bottom offshore wind turbine, right?
Floating, yeah.
So we're talking fixed bottom records being broken. Which I guess is relevant to floating as well, because obviously the deeper that you can install a fixed bottom turbine, the less of a case there is for floating, for now at least. I know a lot of people think that floating is eventually going to end up cheaper than fixed bottom in a lot of cases, but we're a long way away from that now at least.
Well, Entrion disagrees on floating because Entrion Wind is working with DNV on a monopile concept that is for water depths up to 100 meters. So they just Entrion Wind just went through a process with DNV as a feasibility study, and DNV blessed it, said, yeah, this is totally feasible and can proceed on to further development and qualification. So there's a lot of question marks about floating wind and trying to determine how deep you can actually make a monopile. And it looks like this Entrion Wind application is basically a really tall monopile with some cables anchored to the sea bottom, much like a circus tent is put up, right? Got the main pole and a couple of cables coming off it. So it's not true monopile, Joel. It's a quasi-monopile, I would call it. But I think isn't it about just keeping it cheaper and just using the same ships and things you already have? So the complexity is less. I think that's where they're going here.
I don't see the I don't see the advantage of it. This is where I'm thinking, and maybe Rosemary along the same lines as this floating wind, is you have to put anchors and or subsea micropiles in for the basically what would be guy wires, right? So why not just put a floating platform out there? You got to do that anyways for the floating platform. Or does it make the installation that much cheaper and easier with the 100-meter monopile?
I guess that it's also about technology readiness, because obviously, a floating platform is going to move around a bit, and it makes a big difference to how much power you can generate. If you've got, your rotor is slightly off axis, then that's going to reduce your power and cause some funky loads that it wasn't designed for. So, we don't quite yet probably know how well the floating wind can perform. Or, with the current technologies, at least.
But I would think like, okay, so Alan, you and I the other day had a conversation with the gentleman about a tension leg platform. So a tension leg platform would, in 100 meters of water, would basically eliminate much of the pitch, roll, heave of the floater. But again, like you said, Rosemary, now I'm kind of combating myself. But the idea of using a monopile would be 2 or 3 piece monopile buried in the mud. It'd probably be easier. It's probably a quicker TRL level 9 product than anything floating.
Yeah, but I do think, it sounds out there that floating wind would eventually become cheaper than fixed bottom, but there are a lot of advantages to it once it matures a bit more. The foundations are easier, right? The kinds of loads that it has to withstand are a bit easier to deal with in the foundations. And then also it should use less steel. I would have thought less materials need to be in the seafloor and in the tower. So that would be an advantage in the long run too. And then one other one that people talk about is, if you've got like a major fault and you need to, take, big components off, say you've got to get blades down and replace bearings, replace generators or bits of the tower, you can tow a floating wind turbine back to the port and do that work there, whereas it's going to be so expensive if you've got, when you've got turbines in 100-meter deep water, they're usually quite far out. If you've got to get crews out there every single day and equipment sitting out there, build a floating hotel for them, it's going to be very expensive for major faults. So I can see, I probably am in the camp that believes that eventually floating will be cheaper than fixed bottom, but I guess timing, it'll be, in my opinion, at least 10 years, maybe it's going to be 20 years before we see that. So I don't know. What do you think about that, Joel?
Yeah, I think you're correct, Rosemary. I think that once we see some more development and we start to see larger commercial scale deployments of offshore floating wind, the cost will come down. I fully believe that. And what I'm thinking about now is, and we kind of know some of the technical limitations or technical hurdles that offshore floating wind is fighting against, because we're talking with people in the industry regularly. This is kind of a new, it's not a crazy concept, right? But it's a newer concept. And I'm wondering what kind of technical hurdles they had to jump or please the DNV people as they certified the feed study to get to the point where they could say it's good to go. And the big one I'm thinking of is VIV, right? Vortex induced vibration.
I wanted to run this by you. Have you ever heard of Ridgway rock bags? They're based in Northern Ireland. That business is amazing. They make bags of rocks and they sell it, and they're known like worldwide for these bags of rocks, which are used to prevent scour and to kind of hold down transmission cables and a bunch of other things. Can you describe what that business is or what it's all about?
Yeah. So Ridgway rock bags is, if you've ever worked offshore, there's a thing called a mattress. And a mattress goes on, instead of something laying on it, sometimes it goes on top of something. So with the current subsea, everything's moving all the time. If you've ever looked at any kind of imagery of the seafloor, it looks just like the waves on the beach or in the desert dunes. Looks the same thing in this undersea. But the difference is most of that is like silty and soft and moves very easily. when you can drop a tool, this happens with ROVs and subsea operations all the time. You can drop a tool. If you drop a tool from an ROV, usually it's gone because it just goes into the silt. Like you're not going to get it back. So when you have, like say an offshore wind farm installation, those 2 to 3 knot currents coming around the monopiles that are into the bottom are going to create scour, right? It's just like when a creek flows by and there's a rock and there's that pool of water behind it that kind of digs out underneath the rock. The same thing happens as water passes by the turbine tower or the monopile. So you'd usually do rock dumps. And a lot of times it's just big ship and they're just taking a crane, dumping rocks, right? If you miss on your rock dumps or you put them in the wrong place, you can very easily damage things. But these rock bags make it a lot more controllable. And they basically build them. You can build them quayside or you can build them out on the vessel as well. But it makes it more controllable to drop larger sums of rocks that stay together. So think of like, if you had a garden hose running across your yard, and when you crank on the water, that garden hose moves and flexes a little bit. Think of that being the power cable or the oil export line or anything, but laying on the seafloor. So you have that force moving it, but you also have water flowing over the top of it, left and right and back and forth. So you want to put some rocks or mattresses along it to keep it pinned down to the bottom of the sea, basically. And that's what these rock dump bags are for. So you go out there and place them on top of the pipeline or the export cable or whatnot to keep them from moving. Because if they move, they start to flex. It's just like bending a paperclip. Boop, eventually they break.
I think that's an amazing business. And the more I see them on LinkedIn, the more I just think, that's genius. There's a lot of technology behind it. I was watching a YouTube video from them where the bags themselves are made out of recycled plastic for a variety of reasons. I thought they were just made out of like chain link fence, like you kind of see it in the States along the interstate highways. But it's a flexible recycled plastic bag that has to last a really long time on the ocean bottom. It's kind of amazing, right? You just don't think about all the associated businesses that are tied up in offshore wind. That's one of them.
Yeah, absolutely.
Our wind farm of the week is Western Spirit Wind in New Mexico. It is actually 4 separate energy projects, Red Cloud, Duran Mesa, Klein's Corners, and Tecolote. There is a little over a gigawatt of installed capacity. Western Spirit Wind represents the most wind power ever constructed in a single phase in the United States. It opened in 2021. It has about 35 employees on site. And Rosemary, they use GE wind turbines. There are 377 GE wind turbines, varying in size from 2.3 to 2.8 megawatts. And Western Spirit is a feeder for California. That energy is sent to kind of the Los Angeles area, to the Los Angeles Department of Water and Power. So you got to cross a couple of states to get yourself from New Mexico all the way to California. But it's a little crazy, right? But it's great for the local community in New Mexico. So about $3 million a year is paid in property taxes in the 3 counties that these wind farms are in. And the transmission line also contributes about $1 million a year in taxes. So there's $4 million hitting the local community from that wind farm. So that's pretty cool. So Western Spirit Wind Project out in New Mexico, you are our wind farm of the week. That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. Please give us a 5-star rating on your podcast platform and subscribe in the show notes below to Uptime Tech News, our weekly newsletter. And check out Rosemary's YouTube channel, Engineering with Rosie. And we'll see you here next week on the Uptime Wind Energy Podcast.